All right, thank you very much. Appreciate you joining the presentation today. We have quite a few networking folks in the house, as we've learned over the last day or so. So today we're going to talk about seamless networking across the edge, the private cloud, and AWS. So a little bit about 128 technology. We've developed what we call a session smart router. If you look back at networking, maybe over the last 20 years or so, we've seen very little innovation in the networking space. It took 128 technology to step out of that mindset and come up with a new approach. What we've done is we've built a router that can control sessions, route sessions individually, but tunnel free. Right? So no VXLAN, no IPsec, no GRE to steer traffic. We can build a multi-node network, and when we build a multi-node network, it's end-to-end, and it's an elastic fabric. It would be challenging to manage a session-oriented networking without a new approach to management. So a big part of what we've done is developed a data model that now describes the network in terms of a business language. So whatever's important to you as a network and cloud user, now you can describe the network in those terms. So no more routing with purely IP addresses. And of course, security's got to be native to the router, right? No more piling on firewalls and additional chains of tools when you could do a directional firewall fully integrated. So what are some use cases? So we look at 128 technology, of course. SD-WAN for us is a use case. When you look at solutions on the market today, 39 of them are bookended tunneling load balancers. The 128T solution is a network fabric. Again, tunnel free. We can steer sessions using metadata with very, very little overhead. So that creates a SD-WAN solution between your branch and the cloud. Of course, hybrid cloud is here to stay, unless you're one of the lucky folks that's 100% cloud native. Hybrid cloud will be here for quite some time. And of course, you can build out a zero trust fabric using the 128T data model. So again, let's look at the evolution, right? We started with edge services. It was all very easy, maybe some internet transport. And then we realized, of course, that private cloud was key. We wanted to have private addressing, private context, security, using borders. But then, of course, we forgot about all the SaaS services that are out there. And sure enough, in the end, we do end up with a hybrid cloud networking environment. So what do you want the network to look like? Well, you want it to be simple, right? If you look at kind of the legacy approach, you might have different tools on-prem. You might have a legacy big iron router. You might have then new software-based tools in the cloud. Really, that should be software-based, 100% software-based, the same experience across that software, homogeneous, right? So the same experience, whether on a branch, whether you're in a data center, whether you're in the AWS cloud, whether you're in a carrier-neutral facility, it should be the homogeneous networking experience. And of course, a single pane of glass, right? No more flipping between regions, no more flipping between branches, and no more flipping between data center, big iron, and hard and software-based solutions in the cloud. And again, high performance can only come from a tunnel-free network. As you know, if you've done a lot of networking in AWS, you've got IPsec bandwidth restrictions. Those can be as low as 1.2 gig. When you go tunnel free, you free yourself of that bandwidth restriction. So again, security is critical, paramount. You need a global access policy. It's not necessarily described in terms of IP addresses and access control lists, kind of legacy constructs. If you have a data model that describes the network, the tenants, and the services that they're using, you can make that data model global. You could have a guest Wi-Fi tenant that spans hundreds of local branches, and you can grant guest Wi-Fi access to cloud resources on a very pinpoint, granular, sometimes we say 5-tuple or 7-tuple basis. So global access policies that are one policy across the entire network is critical. Directional isolation. Just because I want to access some services in the cloud doesn't mean I need to have bidirectional routing through my entire enterprise network where I've got to now lock it down with access control lists, right? So if you've got a directional network fabric where you're connecting tenants with the services they consume, now you have a better security posture. And of course, reliability. Tried to buy a Starbucks and the network was down. Go figure, about an hour ago. Of course, if you've got multipath, if you've got the ability to migrate sessions between those multiple paths, it could be your direct connect, it could be an internet-based path from a branch, you could use LTE. It's your choice of transport these days between your branch locations and the cloud. But that branch connectivity, multiple connection options wouldn't be good unless you could migrate your sessions between them. So let's look at some folks that are using this technology. We've got an analytics, right? Software as a service-based company. They had a rather large footprint in the customer premise, right? The data for them is within the customer facility, right? We talk about pure cloud and 100% cloud-based solutions, but that data is coming from somewhere else. They wanted to get that hardware-based footprint out of the customer premise, right? Less to manage. They wanted to carry that data securely, seamlessly, right? They don't have control over their customer network, right? It could be any IP addressing. It could be any sort of firewall or internet-based transport. And they needed something that could cross those boundaries seamlessly, deliver the data from their customer premise up to their SaaS-based solution in the cloud. And so what they did was they, first developed an AWS, as we all do, and migrated most entirety of their application up to the cloud. But now they still have to get the data from the prem up to that solution. So by deploying a very simple 128T branch node, right, and this is running on x86, it could be deployed as a simple appliance or software running on your choice of platform, they're able to now transport that data seamlessly with security, encryption, visibility, management from that premise to AWS. So that reduces their time for revenue, right? So they can simply drop in a node that they know they can get network transport up to AWS. Gives them more service availability. As we know, AWS is extremely reliable. They can run transport to multiple regions seamlessly. They can migrate between them seamlessly. And of course, they've simplified their deployment. And now they've got visibility. Now they understand the SLA between the customer premise and AWS, latency loss and jitter. They can have multiple links that reach their service. And it's so much easier to troubleshoot, and they've got full visibility. So what does it look like in production? Again, it's very easy to run across multiple regions, so they do so. Very easy to run across multiple VPCs. They deploy a 128T node in the customer branch site. They have multiple customers. They want to bring segmentation, right? Security and segmentation, right? They can't mix their customers' data. They can't mix their customers' network paths. So they bring that traffic seamlessly, securely, without tunnels, up to AWS and into the enclave appropriate for that customer. They get improved visibility. You can do troubleshooting down to each individual session. You could generate NetFlow or IPFix data for every session traversing the boundary. You now have a full visibility, full auditing, full accounting, and control over that network visibility within their own environment, right? And of course, now their services are elastic. The 128T node is elastic. They can spin that up in the cloud on demand as their customer base has been growing quite rapidly. And so they're more confident in deploying into their customer premise because they have the networking problem solved, and they can take better advantage of AWS services without worrying about those boundaries between the data and the Elastic services. Let's look at another, of course, enhanced reliability. Let's look at another use case, manufacturing interconnect. They kind of went old school. You know, so many folks say, don't bring that old school networking mentality to the cloud. Don't bring this sort of big iron mindset and appliance mindset to the cloud. These guys, unfortunately, took one crack at that and found that they were bandwidth constrained, functionality constrained, and very expensive trying to do security between their prem and AWS. And they had these very expensive direct connects deployed. So they came to 128T, and we said, all right, we've got FIPS certified encryption between your premise and any AWS region. We can deploy a bare metal node or virtualized node in the prem, do very high performance encryption, again without tunnels, so you don't have the 1.2 gig limitation, and they found us to be extremely high performance. How high performance? Well, enhanced networking, it's not easy. Somebody's got to do it. but 128T has tackled the challenge. That's it's a big reward. You will see upwards of 40 gig encrypted performance, traffic performance, if you've got the bandwidth within the VPC. So intra VPC, we've tested all the way up to nearly 50 gig throughput now on AWS instances. We have customers asking for 100 gig. We're doing 100 gig testing as well, and some new instances that give you that kind of throughput. So really we're instance limited when it comes to bandwidth inside the cloud. And then, of course, the direct connects at 10 gig. A lot of customers are trying to get that to 100 gig. 128T is right there with 10 to 100 gig direct connect performance. And what we did find, which not many folks actually come across because there are so many bandwidth restrictions due to tunnels, that there's a 5 gig inter-VPC restriction that we hit very easily and rapidly with a 128T tunnel-free approach. Again, your network is no longer restricted by boundaries. You get full encryption. You get full security between your prem and the cloud. So let's look at, let's kind of compare history. Let's kind of compare the old school thought, with 128 technology and talk about some advantages, right? So again, big iron, it's old school. It's hardware mentality. It's more expensive. You will be, trying to deploy hardware where hardware can't be deployed. 128T, 100% software. Again, it can run virtualized in the branch, in the data center, all the way up seamlessly into AWS, carrier colo, your choice. So you're simplifying the network. You have better visibility, better control. Again, a movement from dedicated resources to shared resources, right? You'll get better economies of scale. You'll be able to pool your resources in the cloud, and then apply global security policies to those shared resources to keep your segmentation, keep your security, keep your encryption end to end. And again, we see tunnels as a legacy technology. I mean, they're still coming out. Press release every day with a new software-defined networking approach, and you look under the hood, and it's VXLAN or IPsec or your choice, GRE out there. Secure vector routing is true innovation in networking. This is different. We are tunnel-free. We send a little bit of metadata from one node to the next when the session is created. That carries the context, that expresses the security, and it's very high performance. Think of it as a fast path, slow path. Very first packet, we send a bit of data. Now every other packet is on a very, very high speed network. And of course, services on site, we're all for migrating to the cloud. Get them there as quick as you can. Make sure that network is seamless. Make sure it's reliable. Make sure it's secure. And you've got session-centric reliability. I think I do have a little bit of time to just kind of give you a quick glimpse of the user interface. We are extremely proud of the ease of use of the solution. And let's see if it comes up here. And HDMI 2 is allowing me to log in. All right, so here we have a glimpse of our single pane of glass. So your resources throughout the network can be managed regardless of the footprint. So the story here is I've got kind of a mix of on-premises, call it a router on-prem in the data center. I've got a couple of remote branches that are feeding some web services, and now I've got nodes within AWS managed just the same as the rest of my network. So I've got full visibility into the bandwidth, session counts, top sessions, top sources, all traffic at the tip of a finger. All of this is an in-memory database. All of that data is queried regardless of the location, and so therefore it's very high performance. So the idea here is that I've got here's a custom service called Elastic Service, right? It's running on-prem, and I've got the green line. The red and the purple are running perfectly fine. They're load balanced on-prem. The green line's running a little bit hot. I'd like to transition some of that capacity over to AWS and fire up a 128T node to migrate my traffic. So it's as simple as starting a 128T node in the cloud. That node will fire up, of course, using a 128T image. We're in the marketplace. it'll reach out to what we call the 128T conductor, which also happens to be running at AWS, and it'll say, hey, what you got for me? You got a config. Do I have interfaces? Do I have services? And the conductor will then transfer configuration back down to the node dynamically. It uses an outbound SSL connection, so it's very simple to bring up and deploy. Again, no IPsec tunnels for management. And as that node comes online, it will establish a peering relationship, right? We're not establishing tunnels. It'll establish a peering relationship with the other nodes in the network, right? And so as that node comes online, you'll see it fire up. And you can see it starting here, right? We have the provisioner starting. We now have visibility into this node that's been started on AWS. It will begin to establish peering paths with other nodes in the network. As you can see, I already have a couple of green peering paths with my AWS Central and my router 1. And now my network is smart enough to have crossed boundaries, right? There's actually a NAT boundary in there. I'm doing encryption between premise and cloud, high-speed encryption, and I'm doing a service-based load balancing. And that service now is come online, and my AWS node is beginning to carry sessions, right? So again, with a session-oriented networking approach, it's easier to fire up services in the cloud. It's easier to transition that traffic and do so and migrate very seamlessly across borders. So I'm running a little bit ahead of schedule. I can take some questions. In fact, if there are
yes.
questions from the audience.
And if you'd like to raise your hand, I'll bring you the microphone. That way everybody can kind of hear.
Tunnel free always triggers some questions, especially with a guy with a Cisco shirt, so I appreciate that.
My bad.
Yeah,
you mentioned FIPS compliancy, so your product is all FIPS compliant?
Yeah, so the FIPS compliance list is public. So if you Google 128 Technology FIPS, you'll find the certification online. That's not an easy thing to do. We actually had to do that up front early on, realize that that we've done this rodeo before. So yes, that was a critical component of the product.
So that's impressive. It caught my eye. Thanks.
Thank you.
Anyone else? Here we go.
Does this work with UDP as well?
I'm sorry?
Does it recognize UDP sessions?
So any session, so UDP sessions, TCP sessions, you could even transport a GRE tunnel across. It's a network router. So we will look like a network router to the rest of the network. We could run BGP, we could run OSPF. The rest of the network will see us as a traditional network node. Once we have the session, be it UDP, be it TCP, we'll transport that session across the fabric. If it's going to another 128T node, we'll send a little bit of metadata, and we'll say, now all this, that session will be on this port pair between those two nodes till its completion. And if it came in UDP, and we don't have any, well, actually UDP will always be UDP on the wire. If it's TCP, we can actually run TCP on the wire. You don't have any flow bunching, you don't have the problems of tunnels and elephant flows.
Thank you.
Sure, thank you.
Anybody else? Questions? All right.
All right, so we do have a booth. We're 128 Technology. I can give you a little bit more of a deep down, drill down demo in the booth. We'd love to have you check us out more. And we think there's room for innovation in networking, and we're happy to have you today. So thanks again.